Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome to Sequential Control Part 11. Today we'll learn about step counter method, but mainly why the name step counter. So basically it counts each step in a sequence of operations, allowing the system to progress step by step in a defined order. The system moves to the next step only when the previous step is completed, and just like advancing through numbered stages, hence it counts steps. So we'll solve a problem, and the problem is like previous: a plus, b plus, b minus, then a minus. So at first we have our two double acting cylinders A and B, and I also gave identification A0 A1 and B0 B1. Okay, to control this I have two 5x2 DCB. Now, to control this 5x2 DCB, I need two 3x2 DCB. But one thing you might notice that this 3x2 DCB is pneumatically operated on both sides. Let's copy this. So now I need two extra things for a single 3x2 DCB. First one is a two pressure valve, or in other word, a AND valve. And a 3x2 DCB which is lever operated or a limit switch operated. So now I will copy these two for each 3x2 DCB. Now I will write some identification for better understanding. Here you can see the sequence, right? A plus, B plus, B minus, A minus. And now I will write this sequence in all 3x2 DCB which are pneumatically operated. So this one is A plus, this one will be B plus, B minus, A minus. The main advantage of this step counter method is that you can solve any kind of sequence with this method. You just have to memorize some connections. That's all. Let's give some basic connection. Okay, so you can see that this 3x2 DCB is connected to the AND valve, and this AND valve is connected to the initialization of A plus, because if this side is initialized or actuates, then a signal will flow here and actuates the left side of this 5x2 DCB, and A1 will initiate. So I'll draw for the remaining valves. So this 3x2 DCB will initiate B plus. So I'll connect this to the cause of B plus, and the cause of B plus is the left side actuation of this 5x2 DCB. So let's connect this in the same manner, and B minus will initiate like this. So I'm connecting it with this region of B minus, and for A minus, let's connect this AND valve to this 3x2 DCB. The region of A minus is this 5x2 DCB's right side. So let's connect this. Now you have to remember this thing. Two lines will emerge from this point. One line will go to the initialization of next step. Another line will go to the termination of the previous step. Okay. So this is A plus. After A plus, there is B plus. So I have to initialize the B plus somehow. And to initialize B plus, I have to give power to this AND valve. Let's connect this point to this AND valve, which is the region of initialization of B plus. Now I have to terminate the previous of A plus, and the previous of A plus is A minus, right? Because Before A plus, there is A minus because it is a loop happening continuously. So how can I terminate A minus? I have to give signal to this side. So obviously I have to connect this dot to, so similarly I have to fill up all the 3 by 2 DCB. For this B plus, I need a point. One is initializing B minus and other is terminating A plus. So for B minus, from the point, one is initializing A minus, another one is terminating B plus. For A minus, one is initializing A plus. Another one is terminating B minus. Okay, so finally done. Now I will show you the identification. For this A plus, the identification will be the previous step. So it will be A0. Now for this B plus, it will be A1. For this B minus, it will be B1. And for this A minus, it will be B0. It's like these are connected. This is same. See, diagonally they are same. Okay, so this is the overall solution. If you connect it like this, any kind of sequence will go as you please. And one thing I forgot to mention is that to initiate this whole sequence, one 3 by 2 DCV has to be initialized in the left side. What is that? So suppose this 3 by 2 DCV, I have initially signal on the right side, right? And you can see all this 3 by 2 DCV has initially signal on its right side. But in order for this method to work, you have to at least select one 3 by 2 DCV, the initial position on the left side. That means the power line and exhaust line have to be this side. It have to be one DCV which has initial position on the left side. Otherwise, this solution won't work. So this is the simulation part. As I mentioned, you can see that I have no 3 by 2 DCB's initial position on the left side. So if I start this sequence, then watch carefully what happens. See, nothing will happen. But if I make this position on the left side, just for the first 3 by 2 DCB, then this circuit will work. See, it works perfectly. Now let me show you step by step what is happening. Let's start clicking the single step. So here you can see the left position was in the initial. So a signal will go here and from A0, A1 will occur. Okay, now A1 is reached. Because of that, this 3 by 2 DCB's limit switch will activate. A signal will go here. There is already a signal on the left side of this AND valve. So ultimately a flow will go to this left side of this 3 by 2 DCB. From that, B1 will initiate. See, here a flow is going here and B1 will complete. This 3 by 2 DCB's limit switch will sense that and this AND valve will initiate and a flow will go here and B minus will occur. See, B minus is happening. So after B minus, this 3 by 2 DCB will actuate, a flow will go here and A0's 3 by 2 DCB will initiate A0 position. See, A1 to A0 is happening. Because of A0, this 3 by 2 DCB limit switch will sense that a flow will go here. There is already flow on the left side of this end valve. Ultimately, another flow will go here, and this 3 by 2's left side will actuate, and A1 will initiate again. See, A1 is happening. So this is the overall solution. I hope you can memorize these steps. Let me give you a summary of that. So I have a double acting cylinder. To control that, I have a 5 by 2 DCB, and for this 5 by 2 DCB, I have 1 and 2 3 by 2 DCB. Okay. For each 3 by 2 DCB, I have a end valve and another 3 by 2 DCB which is operated by a limit switch. I will copy that in all sides. Now I will give identification as the sequence required, give power to the sequence required, and connect like this and this. Do this for all these 3 by 2 DCB. Okay. Two line will initiate. One will initiate the next step, another will terminate the previous step, and the lower identification is previous to this first one, or they are diagonally matched. So if you can memorize these rules, then step counter will be very easy for you. You can basically solve any kind of sequence. So that's all for today. If you have any confusion or you need another video for understanding, please let me know. Allah Hafiz.